All right, let's talk about one of the biggest ideas out there, something that's totally exploded from the world of physics into, well, pretty much everywhere, the multiverse.
You know, this comment from a Reddit thread on the Mandela effect, it really hits the nail on the head, doesn't it? It gets right to the heart of what we're going to explore. Are all these alternate timelines and parallel worlds just awesome sci-fi, or is there some actual physics behind it all? Let's find out.
Okay, so first things first, we got to acknowledge it. The multiverse is everywhere in our culture right now. It's an absolute obsession. I mean, just look at this list. From the Marvel movies to incredible films like Everything, Everywhere, All at Once, to shows like Rick and Morty, Hollywood is completely in love with the multiverse. And why wouldn't they be? It's the ultimate storytelling sandbox, right? You get endless possibilities, crazy alternate versions of characters. It is a total creative goldmine.
But that's the movies. What about the real world? What do actual scientists think? We're so used to the idea now, but does it have any basis in reality? Let's start with maybe the most intuitive idea, the possibility that our universe isn't the only one out there.
So, could our universe have cosmic neighbors? Well, you might be surprised to hear that a lot of physicists think, yeah, it's possible. There are some really big mainstream theories that picture other universes as like separate bubbles floating around in the fabric of space-time. And what's so wild is that you've got these three totally different ideas in physics that all point to the same conclusion. It's not just one theory. First, you've got cosmological inflation, the idea that our Big Bang was just one of countless bangs, creating this huge cosmic foam of bubble universes. Then there's string theory, which, just to make the math work, needs a bunch of extra dimensions. And hey, maybe other universes are just hanging out in those dimensions. And then my personal favorite, this crazy idea that every single black hole, and we're talking maybe 40 trillion of them in our universe, could be a gateway to a brand new baby universe. Mind-blowing, right? Okay, but here's the really important thing to remember about these cosmic neighbors. They're probably totally unreachable, and they might have completely different laws of physics. So this isn't the evil twin with a goatee kind of multiverse. But there's another theory, one that doesn't come from staring at the stars, but from looking at the tiniest particles imaginable. And this one hits a lot closer to home.
So let's get into our prime suspect. It's called the Many Worlds Interpretation, or MWI for short. And this idea isn't born from cosmology, from the study of the universe. Nope, it comes from the absolutely bizarre, topsy-turvy rules of quantum mechanics.
Okay, so the whole thing kicks off with this quantum weirdness called superposition. Basically, for a tiny particle, like an electron, it can be in multiple states at once. It's like a spinning coin that's both heads and tails at the same time until you look at it. So why do we only see one thing? Why does the coin land on heads or tails? Well, the old school explanation, the Copenhagen interpretation, had an answer for that. It's called wave function collapse. The idea is that the very act of looking at it, of measuring it, forces the particle to choose a state. Poof! All the other possibilities just disappear. But then along comes this physicist, Hugh Everett, in the 50s, and he looks at this and says, wait a minute, this collapse thing, it feels like a patch. It's not actually in the math. So he came up with a much, much wilder idea. Everett's idea is just beautiful in its simplicity. He just said, what if there is no collapse? What if the math is telling us the truth, that all those possibilities are real? So when that quantum coin lands, reality doesn't pick heads or tails. Instead, the universe itself splits in two. In one universe, it's heads. In a brand new, equally real universe, it's tails. This is where the famous Schrödinger's cat thought experiment really helps. You've got the cat in the box, and its fate is tied to a quantum event. So before you open it, the cat is in a superposition of being both alive and dead. According to many worlds, when you open that box, you don't cause the cat to be one or the other. No, reality branches. You find yourself in the universe where the cat is alive, but in a parallel, equally real world, another version of you just opened the box to find a dead cat. Both things happened. So you can see how elegant this is, right? It just takes the math at face value. But the price you pay for that elegance is, well, it's huge. You get an almost infinite number of parallel worlds splitting off every single moment. And as you can imagine, this has led to a massive debate in physics that's still going on. So let's put this theory on trial. Okay, so in one corner, the case for many worlds. Proponents say, look, it's just the math. It's clean. It removes this weird made-up collapse idea and doesn't give humans a special magical role. But in the other corner, the case against it is pretty strong too. Critics say, hold on, you're asking us to believe in a stupendous number of unseen worlds just to solve a measurement problem? That's not science, that's metaphysics. Plus, if everything happens, what do probabilities even mean?
So, who's winning the debate? What do physicists actually think? Well, if you poll them at conferences, you find something really interesting. The traditional Copenhagen view is usually still number one, but many worlds is almost always a very strong number two. So this is absolutely not some fringe idea. It's a major player in the quantum world, even if it's super controversial.
And the arguments don't stop. People are still poking holes in this. For example, a recent paper basically says that many worlds commits a huge logical error. They call it a holistic inference loop. In simple terms, it's like the theory has to assume it's true for the whole universe just to explain one tiny experiment. And, well, that's kind of circular reasoning, not really how science should work.
But the supporters of many worlds have a potential ace up their sleeve. And it's not a thought experiment. It's a real piece of technology, the quantum computer. One of its biggest champions, David Deutsch, makes a bold claim. He says that the way quantum computers work is pretty much direct proof that these other worlds are real.
Okay, get your head around this. A quantum computer uses superposition to do a massive number of calculations all at the same time. A computer with just 300 quantum bits, or qubits, could be doing more calculations at once than there are atoms in the entire known universe. So Deutsch's question to the skeptics is just perfect. He asks, if all that computing isn't happening in other universes, then where is it happening? It's a really tough question to answer.
So after all that, from sci-fi to cosmology to the weirdness of the quantum world, where do we land? What's the verdict on the multiverse?
Here's the bottom line. Many worlds is an absolutely beautiful, powerful idea. It takes the quantum rulebook and reads it literally. But, and this is a huge but, it's still an interpretation. It's not a proven theory. It's one possible answer to a deep mystery. And what's so cool about it is that it forces us to grapple with the biggest questions of all. What is reality? And what is our place in it?
And I want to leave you with one last kind of mind-bending thought. If many worlds is right, then every quantum event, every tiny choice splits the universe. That means countless versions of you are being created right now, this very second. One where you skipped this explainer, one where you had something different for breakfast. So if every possibility becomes a reality somewhere, what does that mean for you, for the person listening to my voice right now? What does it mean for the choices you're about to make in this one single branch of reality?